All right, finding inverse of a log function and graphing logarithmic functions as well. We'll skip over that. Finding the inverse of a the following function. Again, first step of finding the inverse of a function is to flip-flop x and y. So we will have x is equal to log base 8 of y. And the next goal was always to solve for y. Now, y is with the log, so the way we do this to solve for y is just rewrite. Again, whenever you rewrite a logarithm to exponential form, you start with the base and go towards the equal sign, end at the argument. So 8 to the x equals y. Then we solve for y. Therefore, the last thing we need to do, make sure we have the proper notation. F inverse of x is equal to 8 to the x. Now remember, we started with the logarithmic function, and if I'm finding the inverse of logs is exponential. Therefore, if we're finding the inverse, we should end with an exponential function. Moving to the next one. One thing that will be easier for a lot of you is rewriting ln, or natural log, as log base e. We'll do that as we are flip-flopping x and y. So x is equal to log base e of y minus 3. Now, the minus 3, since that is in parentheses, that is part of our argument. That's part of the log, meaning we can't move that 3 over quite yet. So at this point, the log is by itself, and our goal is to solve for y. So we're going to rewrite. So we got e to the x is equal to y minus 3. So the last step would be to add 3 to both sides. So e to the x plus 3 is equal to y. And then there is, since we solved for y, there's our inverse. So I'm just going to give us the proper notation. Now, I do want to do this. Let's say we had y is equal to the natural log of x minus 3. There is a difference between this and the purple. Okay. In the purple, the minus 3, that was part of your argument. In the red, the minus 3 is not. That's saying log base e of x, okay, that's your value, minus 3. So in the case in the red, we would actually have to add the 3 over first. So we have, well, we didn't flip-flop, so let's say we flip-flop. So we're going to have x plus 3 is equal to ln of y, or x plus 3 is equal to log base e of y. Now that we have the log by itself, this is the point where we rewrite. So e to the x plus 3 equals y. Okay, y is by itself. So a big thing I wanted to get by with this, make sure you're looking for the parentheses. If it's in parentheses, it's part of the argument. If it's not, it is just a value you're adding or subtracting at the end. So be careful with those. Because the plus 3 in the red is part of the exponent. In the purple, it's adding the value of 3. Okay, graphing logarithmic functions now. Okay, again, we've done the blue. We've done exponential growth and decay. Okay, here we have exponential growth. And since logarithms are the inverses of exponents, if you remember, the graphs of inverses are always reflected over that line of y equals x. So the red is what our logarithmic functions are going to look like. Okay. If you look here, again, you're going to notice h and k. We're not going to worry about those a values yet. Again, h, k. H is our shift left and right. K is our up and down. And we're going to have our new asymptote again. Okay, so looking at the first one, I see I could rewrite this as x minus 0 plus 0. H will always be in parentheses with x. So our hk in this case is 0, 0. There's our origin. And then if you think, on our exponential graphs that had a horizontal asymptote, and since we are doing the inverse of that now, we are going to have vertical asymptotes. And for our tables in these ones, it's going to be a little bit different. What we're going to do, okay, I could write this as y is equal to log base 3 of x. We're going to rewrite this. If I rewrote that, that'd be 3 to the y is equal to x. And that's what I'm going to use for my table. We're just doing an xy table. And now, when we did exponentials, we did negative 1, 0, 1 in x. For logs, we're going to do negative 1, 0, 1 in y. Okay. Now, when we take these values, we're saying 3 to the negative first because it's 3 to the y. Y is negative 1. Okay. Just replacing those and they're there, which is 1/3. 3 to the 0, anything to 0 is 1. 3 to the first, that is 3. Now, this is still our x column here, meaning that is how far left and right we're going to go. Now, with logs, it's always going to go to the right. Okay, and we have a restriction where the argument can never be negative, so it's always going to be to the right of that vertical asymptote. So in this case, it's saying right 1/3, down 1. Right 1/3, down 1. And again, we're always going from that new origin, just right 1, right 3, up 1. And when you're doing this, make sure you're going through the coordinate plane, and then as we approach the asymptote, the closer and closer we get. So anytime you have log base 3, this is the table you'll use always. Okay. So in this case, again, we got an asymptote of 0, 0. So mark that, and we have a vertical asymptote going through that new origin. Okay. So now it's log base 4. So if I rewrite that, again, f of x is just y. 4 to the y is equal to x. So that's what I'm going to use in my table for my xy. Negative 1, 0, 1. 4 to the negative first is 1/4. 4 to the 0 power is 1. 4 to the first is 4. So we're going right 1/4, down 1, right 1, right 4, up 1. So a lot of these graphs are going to look very similar. They do have their differences though. Okay, so getting a little more difficult. Let's get those values in for h and k. So again, remember, we should have these be equations. X minus h, so hk in this case will be 3 plus k, so 1. So we get 3, 1. Again, we still have those vertical asymptotes. So drawing those in there. And again, asymptotes should always be dashed just because they're not technically part of our graph. They're just there to help us plot everything. So, and now, once we have our new origin, we're not worried about that minus 3 and the plus 1. So 4 to the y is equal to x. So when we do our table, we just have that 4 to the y. Negative 1, 0, 1. 1/4. We just got done doing this table. Anytime it's log base 4, that is the table we're going to use. So 1/4, right 1/4, down 1, right 1, right 4, up 1. Okay, so log base 4 again. So guess what? We're going to use this same table on this one. It's just a matter of a different h and k, which in this case is negative 2, negative 3. So we just got that new origin, negative 2, negative 3. Still got that vertical asymptote since it's a logarithmic function. And we're going to go right 1/4, down 1, right 1, right 4, up 1. Okay, that's all there is to graphing logs. And again, anytime you got, let's say it was log base 2 of x on your table, it's going to be x is equal to 2 to the y, negative 1, 0, 1. It's going to be 1/2, 1, 2. If it was log base 3 of x, that's going to be x is equal to 3 to the y, negative 1, 0, 1. 1/3, 1, 3. If it was log base 4 of x, you got x is equal to log 4 to the y, y, 1/4, 1, 4, negative 1, 0, 1. Okay, if you notice the pattern, so even if we had log base, let's say log base 10. Now let's do log base 8 of x. So then it's going to be x is equal to 8 to the y, it's going to be 1/8, 1/8, negative 1, 0, 1. Okay, and as long as it's a log, in green case, log base 8, that's the table you're going to use. No matter what h and k is, that's the table you use. Log base 4, you're going to use that table. Log base 3, log base 2. Okay, so hopefully you can see the pattern for the tables. It all depends on what the log base is. All right, that is finding the inverse